Today we're going to talk about the graphing relationships. Here I have a Cartesian coordinate system which describes the relationship between the y-axis and the x-axis. We use this grid to help us draw relationships between these two variables. So if I were to draw a line on this grid, this line describes how y changes as I change x. So if I move 1 to the x, y goes up 1. For every x that moves to the right, I move 1 up along the y. So this graph describes the relationship between y equals x. This line, like all lines, are shown and written in the form of y equals mx plus b. This is the general equation form for any line graph, or what we call linear graphs. These linear graphs are straight lines, so there can't be any curves or waves in them. Those will not be considered a linear graph. In this equation, the m value describes the steepness of the line. If you think to skiing, it tells me the slope of the line. The higher the slope, the steeper the line. The b value in this equation describes the starting point. So if I were to think of a skier on a hill, the m will describe how tall this hill is for the skier. So the bigger the m, the steeper the cliff. The smaller the m, the shallower the cliff. The b value then, you can think of, is where the slope starts at. So if I were to plot this hill on my Cartesian coordinate, here's my y-axis. The b value is where the skier starts on the hill. And the same with this other example. So here, I start at a smaller b value than this graph here. Some graphs have a starting value of 0. So this line, y equals kx, starts when y equals 0. Other graphs have a starting value that is not equal to 0. In this example here, we have a line that starts at some value along the y-axis. And so the equation has this plus b component, whereas the previous equation did not have a b component because b was equal to 0.